Okay, let's go back and look at this last problem just a little bit, the perimeter problem, and see what makes sense with it. Okay, let's say x was 6, for instance. If x was 6, then it'd be a tall, skinny rectangle, right? Yeah. So it would be 2 here, and the height would be 6 over, so the height would be 30 divided by 4, or 15 over 2, right? Okay, yeah. So what would be the perimeter of this? Well, 15 over 2 plus 15 over 2 is 15. 2 plus 2 is 4. So it would be 15 plus 4, which is 19. Okay. Then if we go and make it 4 wide, how tall would it be? Five. Because 5/4 of 4 is, and so on. And so then this would be 18. Okay. Then if we made it like, if x was 2, then these two would be 6. And what's 5/4 times 2? What's 5/4 times 2? 5/2, right? 2.5. So 5 and 5, or 5/2 plus 5/2 is 5, plus 12 is 17. So as x gets smaller, what's happening here? Perimeter keeps getting smaller. So as it gets smaller, there's not a maximum here, because the perimeter will be the smallest when x equals basically 8, but then that doesn't make a rectangle, so that's why it doesn't make sense, and so that's why there is not an answer. Okay? Now for the areas to be the largest area, let's kind of do the same thing. We'll look at it this way first, and then we'll do the math on it. Okay? If x equals 6, then it's 2 by what? What did we say? It was 2 by 15/2, right? Which is 15 for the area. If x equals 4, it's 4 by 5, or 20 for the area, right? If x equals 2, then it's 6 times 5/2, or back down to 15 for the area. Okay? So notice how the area gets bigger and then smaller again. So there's got to be a maximum value somewhere in there. Okay? That's kind of the extreme value theorem, or the mean value theorem going on there, that there is something bigger than something else. So let's do the math on this and figure it out. If x is here, and this is x minus, or this is 8 minus x, and the height of this is always 5/4 x because of the slope, how do I find the area of that rectangle? What would be the area? Well, what's the base? Come on, calculus people. What is the base of that green rectangle? 8 minus x. What's the height? 5/4 x. Because it depends where you are on the x-axis, because your slope is 5/4. Okay? So if x was 1, it'd be a height of 5/4. If x is 2, it'd be a height of 5/2. If x is 6, it'd be a height of, what did we say? The height was 15 halves, okay? So if we do the math here, the area is, what's 5/4 of 8? What's 5/4 times 8? 10x minus 5/4 x squared. What's the first derivative of that? 10 minus 5 halves x. So the first derivative equals 0. Solve. 10 equals 5 halves x. X winds up, if you multiply by 2/5, you get 4. So this happens to be our maximum area when x is equal to 4. So what is the area? The area is 20. Okay, let's look at this one. Positive numbers, two positive numbers. One is x and one is a minus x, and they have a sum of a. Because if you had positive numbers of 3 and 5, if this was x, this is a minus x, because if they add up to 8, 8 minus 3 is 5. So this is a minus x when this is a. Okay? What is x in terms of their product? That's a maximum. So you want this to be a maximum. Okay? So their product is x times a minus x, right? Or their product is ax minus x squared. So to find the maximum, we find the first derivative. What's the first derivative of ax? This is a number now. This is not a variable. It's a number. So it's just a minus 2x. So the first derivative equals 0. Now solve. So a equals 2x divided by 2. X equals a over 2. So a over 2 would be the value that would give the area, or the product, the maximum. Ooh. 2 cosine of x would be a function that looked like that. The sine of 2x would be a function that looked like this. What's the largest distance in between these two curves going to be? What's the largest distance in between these two curves going to be? Where does it happen at? Somewhere in between negative pi over 2 and pi over 4. Okay? Well, find the distance of it. It's this y value minus this y value. Or 2 cosine of x minus sine of 2x. Because that's how we find the distance, the difference of their y values. And y equals this, y equals that. Okay? So, to find the largest distance, we take the first derivative. What's the first derivative of 2 cosine of x? Negative 2 sine of x. What's the first derivative of the sine of 2x? 2 cosine of 2x. Very good. Way to use the rule, the chain rule. There. It was, wanted to say it, but it wouldn't come out of my head. So that the first derivative equals 0. So negative 2 cosine of 2x must be equal to 2 sine of x. Actually, we don't want to do that. What's the cosine of 2x equal to? Ooh, harken back to trig. There's three things that the cosine of 2x was equal to. The cosine of 2x was equal to cosine squared of x minus sine squared of x. It was equal to 2 cosine squared of x minus 1. And it was equal to 1 minus 2 sine squared of x. Remember that? Those are on your note cards. Okay, which of these three would be most advantageous to use in this situation? The bottom one, because then we only have just signs. Then we basically only have one variable. So you set negative 2 sine of x minus 2 times 1 minus 2 sine squared of x equals 0. Do the distributive property. Negative 2 sine of x minus 2 plus 4 sine squared of x equals 0. If we divide everything by 2 and reorder it, we get 2 sine squared of x minus sine of x minus 1 equals 0. Factor. And that's a positive here. Let's factor this. 2 sine of x and sine of x. Plus and minus, what are the factors of 1? 1 and 1. So 2 sine of x plus 1 equals 0. Sine of x equals negative 1, or 2 sine of x equals negative 1. So sine of x equals negative 1/2. And sine of x equals a positive 1. Where does the sine of x equal 1 at? Where on the unit circle does sine of x equal 1? Nope. Pi over 2. Where is the sine of x equal negative 1/2 at? 2 places on the unit circle. At 7 pi over 6 and 11 pi over 6, right? Okay. So, they say at the start of this problem, it needs to be in between these two. So on our unit circle, in between negative pi over 2 and pi over 4, is pi over 2 going to be in between negative pi over 2 and pi over 4? No. Are these two in between it? No, unless we use coterminal angles. What's the coterminal angle with this? Well, it's negative 5 pi over 6, which, is that in there? Yeah, that would be in there. And then this is negative pi over 6. So looking at these answers, hey, negative pi over 6 is an answer. So that's a little trig throwback that you might see. Last one, okay? Consider the function 9 minus x squared. That's the upside down parabola here. The shaded region of the isosceles triangle is where it touches this. So another isosceles triangle might look like this. Okay? Where this is x and this is f of x. Okay? So we want to know which triangle would have the largest area. This skinny little one, or this one, or a really fat one that looks like this. Well, to figure out the area of a triangle is 1/2 the base times the height, right? So the area of this one they have drawn right now, it goes from here to here is x. How far is it from here back to here? How far is that? If it's x from here to here, how far is it from here to here? X, because distance is never negative. So what's your base going to be? 2x. What's your height going to be? Well, your height is f of x, right? Well, f of x is this. So you take it 9 minus x squared. So if we multiply, a equals 1/2 and 2 cancel, x distributed to 9x minus x cubed. What's the first derivative of that? equals 0. So 9 equals 3x squared. Divide by 3. X squared equals 3. So x must equal the square root of 3. So if x is the square root of 3, plug it in the area formula. 1/2. The base is 2x, so it's 2 square root of 3. The height is 9 minus 3, because square root of 3 squared is 3. So half of 2 cancels, so it's 6 square root of 3. Ta-da. Okay? That's optimization. I gave you most of the homework problems that you'll see. So you cheaters, I'm not going to call you cheaters.